Hello everyone. In this video, we will be performing prediction using supervised ML. The aim of this task is to predict the optimum number of clusters for the given iris dataset and represent it visually. I have used Python 3 as the programming language and Jupyter Notebook as the IDE. The type of the task is the k-means clustering. Now, there are a number of steps to be followed when we are designing a k-means clustering algorithm. A few of them have been noted down here. Step 1 is to import the dataset. Step 2 is to visualize and analyze the dataset. Step 3 is to design the k-means clustering algorithm for optimal clusters. Step 4 is to plot the k-means clustering graph and identify the optimum number of clusters from the graph. Step 5 is visualizing the clusters, make predictions, and finally to evaluate the model. So let's get into building our model. So the step 1 is to import the dataset. We would be using the iris dataset, which I have imported using the sklearn datasets, which are already available. Then I have created a data frame, which includes the values of the iris dataset as well as the columns. As you can see, we have sepal length, sepal width, petal length, and petal width in centimeters. Next, the iris df.head displays the first 5 rows of the dataset. The iris df.shape displays the dimensions of the dataset, which means that there are 150 rows and 4 columns. Next, we have the describe method, which displays the numerical insights on the dataset, such as what is the total count of the data, what is the average or the mean of the data, what is the standard deviation, the minimum and the maximum values, and so on. Next, before we start building the model, we need to first check for null values. So this is what I have done here, and we can see that there are no null values in the data set. If there were any null values present, we would have to deal with them by either replacing the null values or just not considering those rows at all. The next step is to visualize and analyze the data set. Now, when it comes to visualizing, the first step that I have done is finding the correlation between the different values in the data set. So what is the correlation between sepal length and sepal width? What's the correlation between sepal length and petal length, and so on? Next, I have also plotted a heat map for the same. As you can see, this is the heat map for the iris dataset. Along with the heat map, I have also done a pair plotting, which considers 2 attributes at a time. And we can see what is, try to find out the relation between the data. So it plots the graph taking 2 attributes, which is sepal length and petal width, sepal length and petal length, sepal width and petal width, and so on. The next task is to design the k-means clustering algorithm. Now, initially, I have extracted the values of all the different attributes into the variable x. Next, I am now defining the k-means clustering algorithm. As we don't know what is the optimal number of clusters, the way to do this is to use a for loop, and I have kept the range as 1 to 10, so that we would never really use a very large number of clusters. So I'm just trying to find what is the optimum number of clusters, and I would be storing the value of each iteration in the variable WCSS, which stands for within cluster sum of squares, and be using that to plot a graph. Now, this is what we have done here. We have plotted the k-means clustering graph to identify what is the optimal number of clusters. When we are using the elbow method, which is the graphical representation of the k-means clustering algorithm, we find that the optimal number of clusters occurs where we find the elbow. That's when the WCSS, which is within cluster sum of squares, doesn't decrease significantly with each iteration. So this is that point, and as we can see, it is close to 3. So we would be considering the optimal number of clusters to be 3. Next, we would be applying the k-means to the dataset or creating a k-means classifier using the optimal number of clusters to be 3. We would then be fitting the model to perform predictions. Once we have done that, we would be visualizing the clusters by using a scatter plot. So I've done the same. I've plotted a scatter graph to visualize what the clusters look like. The red ones are iris setosa, the blue ones are iris versicolor, the green ones are iris virginica, and the yellow ones are the centroids of each cluster. The next step is to make predictions. Now, X contains the sepal length and the sepal width, and Y contains the target species value. So I have just printed out X and Y so that we can see what values the variable contains. And next, I would be visualizing the X and Y variables in a graphical form. So again, I have used a scatter plot and I have done the same. Here, X, these two values represent the sepal length and the sepal width. And the C stands for, it's like what are the target variables that we will be concentrating on, which is basically the three types of iris flowers that we have. The next step is to evaluate the model, which is comparing the actual versus the predicted data values. Before we do that, we would be creating labels for the data, so which basically tells us which cluster the given data point belongs to. So this is what the new labels look like. And then I would be plotting a graph to identify which cluster particular data point of flower belongs to, and what is the difference between the actual values and what is the predicted values. So as you can see, these are the different clusters for the actual data points, and this is what we have predicted, which is almost really similar, and it's quite efficient, as you can see. So this is how the k-means clustering algorithm works, and that's all for today. Thank you.